Hello 108 class, Mr. McHugh here. Welcome you to section 7.2 where we are going to add and subtract rational expressions. Okay, so we're going to tackle objective 1 here, and just like with fractions, if you have the same denominator, what do you do with the numerator? And here's I usually get on there and talk about pizzas in my class, and what happens if you had two pizzas. They were cut in 6, and out of the one they had pepperoni mushrooms. 2 of them were eaten out of that, and over here you had 3 of your veggies eaten, veggie pizza. And if we were going to ask how many total slices were gone here, I'm just trying to do this real quick. Here's 2 here. 1, 2, 3. 3 plus 2 slices, you would equal 5 out of 6. But why were we allowed to do that? What can I say about the denominators? They were the same. That slice of pie was the same. So you always have to have the same denominator. And so we're going to start off with easy ones here. When you already are going to have rational expressions with the same denominators, you simply are going to add or subtract the numerators, the top half, and to basically get your results. Okay, so think of your concepts of adding and subtracting fractions now. This page starts off with basically the same denominator, so we will just tackle that, and then we'll tackle the harder ones on the next page. Okay, so a couple guidelines. 1, add or subtract the numerators. Again, when you've got the same denominator. 2, if I say denoms, that means denominator are different, then you must determine the LCD. That's what we'll do in the next page. You have to convert the rational expressions into the LCD, into the denominators, just like you do with regular fractions. I'll show that on our next page. Now add or subtract the numerators and then simplify. There's your 5-step process here. Okay, so starting off here, some warm-up problems. Again, basically not too easy. What are you recognizing here in this problem? You've got the same denominator, you've got subtraction, so 7 minus 11 is negative 4 divided by the common denominator, 2r squared. Okay, and then I forgot to add this, but can you simplify this a little bit? Doesn't 2 go into both 4 and 2, so couldn't you write negative 2 over r squared? Okay, don't forget that. So we're cruising here, looking at example 1C. Looks a little tougher, but what we got here is the key thing is you're adding 2 rational expressions and the denominators are exactly the same. As soon as you see that, you're in easy street. Keep the denominator. It's a common denominator if you want to call it that. It's the same thing. Add the numerators m plus p. Now you think you're done, and then before you simplify, you got to say factor, factor, factor. I know I'm a broken record here, because m squared minus p squared, what does that look like? You got it. Difference of squares. Factor it out. M plus p times m minus p. Difference of squares. So once you've done that, look what the magic happens. You factored, so now that you've got factors in the denominator, and you find out that m plus 3 is both the numerator and the denominator cancels out because it's equal to 1, and you're left with 1 divided by m minus p. Remember, if you wanted to, you could put this 1 here. If you wonder where that 1 came from, there's always a built-in automatic coefficient of 1. 1 times anything does not change the value. Okay, let's see what we got at the bottom here. Oh, one more example here. Now this one, you go, I'm lucking out, because do you have the exact same denominators? And the answer is yes. So keep that denominator. Oops, I didn't give myself enough room, did I? Add the numerators, 4 plus x. Okay, now from here, that step's optional. You might or might not needed it. You ask yourself, can you factor the denominator? And the answer is yes, by reverse FOIL. So you write out the factors x plus 4 times x minus 2. Then you realize you've got like factors stacked on top of each other are equal to 1, and now you're left with 1 divided by x minus 2, and there's your answer. Okay, hey, we got cruising on page 1. We'll check off on here. We're done. Page 2, we're going to deal with some problems here. We're going to work on LCDs, trying to understand that concept. So I will see you on page 2 on the next video. Okay, take care. I'll see you. Bye.